Hi everyone, this video is a lesson for topic 3. Predict whether a spontaneous reaction will happen. So, what is a spontaneous reaction? Here's a quick definition. A spontaneous reaction is a reaction which occurs by itself, without outside assistance. To determine whether a spontaneous reaction will occur, the first thing we need to do is look at the standard potential reduction table. This table will tell you which species have a greater tendency to oxidize than others, and which species have a greater tendency to reduce than others. Remember, oxidizing agents are on the left side of the table, while the reducing agents are on the right side of the table. All the half reactions on this table are written as reduction half reactions, and the oxidizing agent are all gaining electrons. And here is how it works. An oxidizing agent on the left will react spontaneously with every reducing agent on the right below it. As you see on the picture, fluorine will react spontaneously with every species on the right, except for F-. So fluorine gas is the strongest oxidizing agent on the table. Now, let's look at a reducing agent on the right. For example, Rb. It will react spontaneously with every oxidizing agent on the left except for Rb+, because it is at the lowest right on the table, and it reacts with every oxidizing agent on the left above it. So Rb solid is the strongest reducing agent. It is really important for you to distinguish the ion of an element and its neutral and atomic form. For example, Rb solid is the strongest reducing agent, and it is very reactive, whereas Rb plus is a very weak oxidizing agent and it's not reactive at all. Let's look at an example. Mg2 plus can react with every reducing agent below it. So the reaction of Mg2 plus and Ca solid is spontaneous. Notice that a backslash is drawn between the two species. So when a backslash can be drawn between two species, the reaction will be spontaneous. Now, let's say we mix Mg2 plus and Mn solid. Mg2 plus will react spontaneously only with the reducing agent that are below it, but Mn is above Mg. So, Mg2 plus does not react spontaneously with Mn. If you draw a line between Mn and Mg2 plus, it is a forward slash instead of a backslash. As you might notice from the earlier examples, if a backslash is drawn between two species on the table, a spontaneous reaction will happen. But if a forward slash is drawn, the reaction will be non-spontaneous. In addition, if the two species are on the same side of the table, the reaction is non-spontaneous as well. Here is an exercise question. Will chlorine gas oxidize silver metal? First, we look at the table. If you connect these two species with the line, it will form a backslash. As a result, the reaction is spontaneous. So, yes, chlorine gas will oxidize silver metal. So here comes exercise 2. Will CO metal reduce I2 solid? Same as exercise 1. You just need to find CO metal and I2 solid on the table. Then connect them. It forms a backslash. So it is a spontaneous reaction. So the answer is yes, CO metal will oxidize I2 solid. Let's move on to exercise 3. The question is, can hydrochloric acid be stored in a copper container? First, we need to identify the species that are taking part in this reaction. In hydrochloric acid, there is H plus ions and Cl minus ions. and the copper container is Cu solid. Same as before, we find those species on the table and then connect them together by a line. There are 3 lines drawn in this situation, and none of them is a backslash. So, the reaction is non-spontaneous. So, we can conclude that hydrochloric acid can be safely stored in a copper container. Here is a reminder for you. Be careful with Fe2+, Sn2+, Cr3+, and Cu+, as these ions are found on both sides of the table. They can act either oxidizing agents or reducing agents. So you have to look at them on both sides of the table when determining the spontaneity of reactions involving these species. That's it for our lesson, and hope you have learned from it.